In this video, I'm going to describe a chessboard capture program. This is a program you will use to capture an image from your monitor of a chessboard, more specifically a chessboard diagram. Once you capture it, the program will convert it into a format that you can put into a chess database or submit to a chess engine. This is useful when you're browsing the web at various chess sites, perhaps watching a chess video, solving a chess puzzle. You see the image on your screen. You'd like to capture it to verify that the position is as the commentator says, that your chess engine thinks it's white to win or not. If you're trying to solve a puzzle and you can't solve it, you can submit it to your chess engine to solve it. If you think you have a better solution or another solution, you can capture the image of the chessboard and submit it to your chess engine to see if your solution is as good as the specified one. This program is free. It runs under Windows 7. It probably runs under earlier versions of Windows, although it's only been tested under Windows 7. You can find this program and you can download it from my website. This is what my website is. I wrote this program. You can find the means of contacting me to submit bug reports or suggested improvements. I'm going to describe how to use this program. I will say that I myself have found it useful since I visit a good number of chess websites. I do watch chess videos, I watch live commentary of chess games, and quite often I have wished that I could easily capture the position and submit it to my database program and to my database engine. That's why I wrote this program. Now let me describe how it works. You download this program from my website by going to the bottom and finding the file chesscapture.zip. Download that to your computer. Unzip the files into any folder of your choice, and then you click on the program to run it. That program is called capturechessboard.exe. As soon as you run the program, the following screen will come up. This is asking you to pick a folder to store the data that the program generates. After you pick a folder, the next window that you will see looks like this. At this point, you are going to designate what I call a chess font. This captures the design of the individual chess pieces. When you start up, you will not normally see a list of chess fonts, but you will have to create one. So you click on New, and the name of the chess font should be after the site that you're going to get the chess diagram from. So for example, if you visit a site to get a daily chess puzzle, you might name this font Daily Chess Puzzle. So let me put that in there. And the idea is that every time you want to capture another diagram from this site, you will use this font to do the capturing. The program has got a kind of learning algorithm where it will be learning the design of these chess pieces. So if you have a different site that you use to watch chess videos, you might name the font after that site, and so forth. So let's go to a site that has a daily chess puzzle and see how this program works. Here I am visiting chess.com, which is a good place to get puzzles, and I've called up a daily puzzle and I want to capture it. Now if I go back to my program and click on Capture Chessboard, the program window disappears and a new one comes up, and this is what I call a reticle. And this reticle has a hole in it, and you can see the desktop underneath it. The idea is that you position this reticle over the chessboard that you want to capture. You stretch it like you would a normal window. Now in placing the reticle over the chessboard, you want to be careful to include the very edges of the outermost square. You can see here I've captured a little bit more than the actual chessboard itself so that I can get this line that delineates the squares on the edges. There are two other things that you have to do. You have to make sure that if black is on top, that this checkbox is checked. Some diagrams, especially if it's black to move, will have white on top and black at the bottom. Similarly, if it's not white to move, you would uncheck this. Once you position the reticle, assured that these check boxes are correctly designated, you just click on Capture. The next thing that comes up is a grayscale version of the chessboard that you just captured, along with an indication of where the program thinks the pieces are, and that's designated with a red square in the upper left-hand corner. And you can see that the program was successful in knowing what squares have pieces on them. Now, before the program has actually learned the font, you're going to have to tell the program what the pieces are. You do that by using these buttons over here, and I found it best to start with the white pieces and just go through all the various piece types. So you start off with a white pawn, click on this button, and then start clicking on the white pawns. Now when you click on one, you can see that it identified actually another one because it's of the same style format as the one you clicked on. If you click again, you can see that it's picked up some more, and finally we will have designated all of the white pawns. Going to the rooks, click on the rook, click on this rook, and you can see that it's picked up the other rook. Click on the knight, click on the bishop, the king, and finally the queen. And let's do the black pieces too. Click on the black pawn, any black pawn. You can see that now it's found almost all of the black pawns. There's still one to go. Click on that. At any given time, you can see how many pieces you have yet to identify. It tells you that down here. It also indicates that by the fact that there's still red squares on the unidentified pieces. So continuing, we'll click on the black rook, and we'll get the knight, and we'll get the bishop. And notice we didn't pick up this black rook, so we're going to have to click on that. So let's go back and pick up that rook. Let's get the queen. And now when we click on the king, you can see that it's given you a finish button here. You've identified all the pieces because the red squares have disappeared. They're replaced by, for a white piece, a white square, for a black piece, a black square. And those squares have the piece designation in them. It's a capital letter for the white pieces and a lowercase letter for the black pieces. Now when you're finished identifying all of these, you click on Finish, and up comes the fen string, which is the format that many database programs would like to have submitted to them. And not only do you see the fen string here, but the program has also copied this string to the clipboard so that you can easily paste it anywhere you want to paste it. You could paste it in a notepad, you can paste it into the chess program itself. Many of these programs, chess database programs, will have a button that just says, I'm assuming the fen is on the clipboard, click this button and I will pick up the position. I'll show you how that works with a database program called SCID. I've written some tutorials on SCID that you can find in YouTube. And here is what SCID looks like. And let me close it up here. There's a menu item on SCID called Edit. And if you go down to the bottom, it says Paste Start Board. So what this program is expecting is that you've already put the fen string on the clipboard. So you click on that. And here's the position that we've just captured. Now from here you can go and open up a chess engine, you can move the pieces around, you can save this diagram into your chess database so you can call it back later if you're making, say, a collection of puzzles. So it was fairly easy to capture that chessboard diagram from any website and easily get it into our SCID database, and in fact into many other databases and chess playing programs. Now let me dismiss this. And the idea of this program is that as you use it on the same chess diagram, in particular the diagram represented by the font, as you continue to do that, it will get smarter and smarter about learning these pieces. So let's capture this again. Now we're going to use this font called Daily Chess Puzzle, and we're going to do another capture. So here's our reticle. It's remembered, because we haven't moved the reticle, it's remembered where it was placed, so you don't have to place it again. We're going to capture the same position. But now when we capture it, you can see that it's identified all the pieces. It doesn't even let you identify them yourself because there's no need to. And it picks up the fen string and automatically puts it on the clipboard. So once a font has been learned by this program, it's essentially one click to capture the diagram and put it into fen format. As you might expect, there are some situations where the program will have difficulty in understanding the chessboard. One fairly regular case is when the black squares of the chessboard are designated not with a solid color, but with hatches. And I'll show you what that looks like next. Here's a chessboard. This diagram is typically used for printing before they had full color printing, and you can see that the dark squares are represented with these hatched diagonal marks. Well, this befuddles the program. It's not going to be able to detect pieces inside hatch marks, and it's not going to be able to really do a good job of detecting that these are black squares. That does not keep you from actually capturing the chessboard, however. It just keeps the program from learning what this font is. So let's see how this would go. Let's go over here and make a new font, and we'll call it Hatch. And we'll ask to capture the chessboard. Here's our reticle. So we're going to place it over this chessboard. And we're going to make sure that we capture enough of it. As a matter of fact, in this case, I'm going to want to get as close as I can to the edges of the chessboard because, in fact, I know it's not going to be able to capture it. So the closer I get to this chessboard, the better I'm going to be able to work with it. Again, you'd verify that these check marks are correct, and you click on Capture. Now, up comes a message saying it can't find the chessboard within the captured image. I won't get into the technical reasons for this, but that's what it means. And so the best you can do is dismiss the message. And you can see that it was unsuccessful in identifying the pieces because there's no little square up in the left-hand corner. What's more, what it thinks is the interior of the squares is accurate in some cases, but not too accurate in other cases. Still, you can identify the pieces, so you just do what you did before. Start with the white pawns, click on the white pawn. Now there is no chance that it's going to be able to figure out what the other white pawn looks like, so you're going to have to click on that explicitly. And when you click on a square, you should make sure that you're inside the red lines here. So when you pick up the king, for example, you go up here, and we might just as well finish this just for the heck of it. And we'll get the white bishop, and we'll get the white queen. And we'll start with the black pieces. We'll get the black pawns. And we'll get the, let's go back, get the white rook. And let's get the white bishop. And let's see, you can tell what you're missing because the squares that are occupied that don't have a little square up there you haven't really identified yet, so we're missing the bishop and the king. So let's get the black bishop. Let's get the black king. Now, if you make a mistake, that's okay. I mean, let's suppose we call this a queen, a black queen. Well, you just correct it. Okay, go over here to the white pawn, click again. Now it's a white pawn. So you'd eyeball this and you'd say, yeah, everything looks okay. And then you click on Finish, and up comes the fen string. So it's possible to capture this chessboard even though the program doesn't really understand what's going on. And that's due to the fact that it's used hatch marks. I don't encounter this style of chessboard very often, but I'm just illustrating that if the program has difficulty, you can keep on going. It's just going to be more manual than it otherwise would have been. Now there's another situation that you might run into, and that's where the chessboard has been annotated with arrows and squares and circles and X's. You see this a lot when you're watching a chess video and the annotator is trying to tell you what's going on. So let's see what happens when this program tries to capture a chessboard under those conditions. Here is a chessboard with those arrows on it, and we're going to capture this chessboard and see what our program can make out of that. Let's start a new font. Let's call this Chess King. I think that's where I got this diagram from. Capture the chessboard. Here's our reticle. We'll be careful about placing our reticle over the chessboard. Again, we'll try and capture a little bit outside the squares so that we give it some lines, outer lines to work with, and click on capture, and it comes up, and you can see it's pretty good at identifying where the pieces are. It knows where the empty squares are, but this arrow is kind of baffling to it. It thinks because there's something here that's not empty, that there's a piece here, and it thinks that there are pieces all along this arrow as well. So we have an option called empty, and you select that and then click on all the squares where it thinks there's a piece but isn't one, and click on those squares, and it will tell you that you've emptied those squares. Now you go through and just identify the pieces like you normally would, and so we'll do the white pawns, and we can see we pick up a lot of white pawns as we click. And let's do the rook, and let's do the bishop. Notice the bishop has got this little arrow here, tail end of that arrow. So we'll click on that, we'll click on the other bishop, and we'll get the king. And it's pretty good about telling you how many squares you've got left to go. So let's just finish this off, get the black pawns, and the black rook, and the knight, and the bishop, and the king. And we're done. We know we're done because the finish button has cropped up and there are no red squares left. Now what you want to do here is you want to check this box called Cancel Learning. The reason is that it thinks that this bishop is really configured or designed to have a little snippet of an arrow on it. Likewise, this rook is got a little snippet of the arrow on it. So you don't want the program to memorize that this is what a rook looks like and this is what a bishop looks like. So if you cancel the learning, it won't get confused the next time you pick up a diagram from Chess King that doesn't have any arrows on it. It'll be much happier. In any case, you click Finish, and here comes the Fen, and there you go. So the program is pretty robust in that you can capture just about anything, no matter what it looks like, by doing the right thing with the empty square and clicking and designating correctly. Now, there's some other features of this program. Not only does it output the Fen strings, but it also puts the diagrams into Pgn format. Sometimes programs would rather have Pgn format than Fen strings. So you can specify the Pgn parameters with another tab on the capture program. If you click on the Pgn params, you see this screen. This button lets you pick the data folder that is going to store the file that will contain the Pgn format of the diagrams that you've captured. Click on Pick, and up will come a dialog that will let you pick that folder. The name of the file that will contain the Pgn is designated in this box. And all of the other Pgn parameters you can fill in just as you please. Now, you don't have to use what they tags really mean. This would be the white player, this would be the black player, but you can put anything in here you want. So for example, if you were capturing puzzles that had a pin theme or a fork theme or a back rank mate theme, you could use that for the white player if you want. That would allow you to search more easily on the theme of the puzzle. The one thing that the program takes over is the site parameter. The program will come up with a unique string for the site across all usages of the capture program. This is handy because if you want to search on the site and get back to a specific screen that you've captured that is a specific position in your database, you can use this unique site key to do it. What I use this for is I can construct a flashcard deck, and the question would be this site string as the question, and then I would call up from the database that particular puzzle, and then the answer would be the solution to the puzzle. So you may find this useful. Now, the way this works is that when you start up the program, it's going to place all of the captures that you do for that run of that program into one file, the file that you've designated here. When the program first starts up, it empties that file. But when you close the program down, or at any time when you're running the program, this file will contain all of the positions that you've captured during the run. And some programs like to accept a file of Pgn positions. In particular, the SCID program that I mentioned before has got an option to do that. Here's our SCID program again. And under Tools, there's an option called Import File of Pgn Games. And now you browse to the file where you've actually captured them, and here it is. And SCID will go in and get those, and it found in that file it had 4 games because I've done 4 captures since I started running the program. And you close that, and you can, if you want, in SCID, get the game list. And here are the 4 games. And if you expand this, you will see the site designation has got a unique identifier, and that there's a search in SCID and most other database programs, so that you search on site so you can bring this thing up for each of the positions uniquely. So that's how the Pgn part of this program works. Now let me describe the remaining 2 tabs. These are not generally useful as you're running the program, but they can be. This tab called Board Limits tells you how the program thinks the board looks. It will draw a red line around the edge of the board and red lines along the interior of the board to designate the outermost squares. And it draws yellow lines to tell you what it thinks the interior of the square is. So this diagram is a good indication of how well the program is finding the chessboard and how well it is knowing where the squares are on the chessboard. If you get the message saying it couldn't find the chessboard, you can look at this and you can sort of see why. Quite often there isn't much you can do about this, but what you can do is recapture the diagram, being more careful about how you place the reticle over the chessboard. The closer to the actual outline, the better, making sure again, though, that you have enough of the area outside the squares so that it can detect the line between the outermost squares and the rest of the chessboard boundary. The other tab is Pieces, and this tells you how the program discovered the pieces. And if it can't find the chessboard, you won't even see this in this form. But if it did find the chessboard, it will make kind of a silhouette of each piece, and this is how it thinks the pieces look. These are rooks, and that's a pawn, that's a bishop. And you can see that because we had arrows on the board, the bishop here has got a little bit of a tag on the end of it, and the rook has got a little bit of a tag on the end of that, because that's where the arrow is, and the program can't really separate the arrow from the piece, and that's why we elected not to learn the pieces from this. So this can be helpful in telling you what the program thinks the pieces look like, and I've used this for debugging, but I think it's useful to have kept it in here so you can see what's going on. Let me close by saying I was inspired to write this program because I was doing some research looking for such a program on the web. The only other one I could find is this program, which is pretty good. It's called Diag Transfer, for diagram transfer. Here's the URL. If you're searching for a program that does this sort of thing, you probably should look at this program. It's pretty functional, and you may actually prefer it over the one I wrote, so give this guy a look if you're interested. In conclusion, here's my website again. Here's the URL. There are instructions on how to download this program. The website also contains a link to the documentation, so if you want to read about it a little bit more, you can go to the documentation before you download it and decide whether or not you really want it. I would appreciate it if you find any bugs or you have any suggestions that you email me. My email address is on the website. You're free to use this any way you wish. You can give it to your friends. The only thing I ask is that you include the documentation with it and that you don't try and sell it. I found this program useful. I had a lot of fun writing it, and I hope you enjoy it. Thank you for your attention.